question is from GATE 2016, Mechanical Engineering paper, set 1, question number 8. The cross sections of two hollow bars made of the same material are concentric circles as shown in the figure. It is given that R3 is greater than R1 and R4 is greater than R2, and that the areas of cross sections are the same. J1 and J2 are the torsional rigidities of the bars on the left and right respectively. The ratio J2 by J1 is. So it is given that R4 is greater than R2. Notice R2 is the outer radius of this hollow bar and R4 is the outer radius of this hollow bar. And R3 is greater than R1. Again, R3 inner radius of the right bar and R1 inner radius of the left bar. Second thing that is given is areas of the two bars are equal. Area of cross section of the two bars are equal. So we can write A1, let this be A1, this be A2. Then A1 is equal to A2. Hence, if we calculate the areas of these bar, it is pi into R2 square minus R1 square. Outer area minus inner area will give the area of this hollow section is equal to pi into, same case with the bigger one, R4 square minus R3 square. So we have the relation R2 square minus R1 square is equal to R4 square minus R3 square. Let this be equation 1. Now they have asked us to calculate J2 by J1, where J represents the torsional rigidity. So we know that torsional rigidity of a bar is given by its shear modulus into the polar moment of inertia of the section. So we can write J2 by J1 is equal to, let's substitute the corresponding torsional rigidities. We have J2 by J1 equal to G2 IP2 divided by G1 IP1. Now it is given that the two bars are made up of same material. So their shear modulus will be equal to each other. Hence we can write this ratio is IP2 by IP1. We'll substitute the values of IP2. So for this one we have pi by 2 into R4 raised to 4 minus R3 raised to 4. This gives the polar moment of inertia. Again for bar number 1 we have pi by 2 into R2 raised to 4 minus R1 raised to 4. Here pi by 2 will get cancelled with pi by 2, but we will not be able to decide whether this difference is greater than the difference in denominator. And that is why we will not be able to identify J2 by J1. So let's use the formula a square minus b square here. So we can separate out the terms. We have R4 square minus R3 square into R4 square plus R3 square divided by, same in the denominator, R2 square minus R1 square into R2 square plus R1 square. Here's when we use equation 1. So by equation 1, we have these terms are equal to each other. So we can cancel them out. The thing that we are remained with is J2 by J1 is equal to R4 square plus R3 square divided by R2 square plus R1 square. R4 is greater than R2 and R3 is greater than R1. So we know here that numerator will be definitely greater than the denominator. This gives us R4 square plus R3 square is greater than R2 square plus R1 square. So if numerator is greater than denominator, we know that the ratio J2 by J1 should be greater than 1. Let's look for the correct option now. So we have that answer in option A. J2 by J1 is greater than 1. To learn more about torsion, you can refer to the NPTEL video, Lecture 18, Torsion 1, from the course Lecture Series on Strength of Materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.